In this video, we are going to be looking at dense rank, and we are going to be using dense rank as the operator. And just as a note, that some languages may not support what's shown in this demo. So in this example, we're going to be looking at some structure of data in which we have products and merchants. And the way the merchants come in is, let's suppose this was coming from a file. The merchants actually come in by name. Now in this case, I'm using vague merchants. These aren't actual merchants. But as we see, we have these names and we have these product IDs. But let's suppose we wanted to give these merchants an identifier and we were wanting to start with this data set. So one of the things that we can do is we can use the dense rank operator. And what the dense rank operator is going to do is it's actually going to partition by essentially the merchant in this case by assigning these an ID. So it's going to rank these and it's going to rank that in those partitions. So we'll see how this works. When we run this, I'm going to go ahead and do star here. And then we will do, let's just do a comparison first as well. If we were to do row number over, and we're going to go do order by merchant, and we'll do row number ID, and then we'll do dense rank, and we're going to do over, and we're going to do order by merchant. And it helps to show this just because dense rank ID side by side so that we can see the difference. So the row number is going to do what we would expect. It's going to mimic this right here. I can't highlight this, but these various row numbers that we see on the side. But the dense rank, it's going to partition by these merchants, right, as the same ID. So as there's a new merchant, if we think about this, as there's a new merchant here, so if I were to select a distinct merchant from this table, I would get A, B, C, D, E, F, G, and I realize that there's three. I'm just doing it very quickly here, but if I were to break that out when I'm using this dense rank operator, that distinct, I would get those distinct. So essentially what it's doing is it's giving us that distinct value as an ID. In this case is how we're doing it. It's giving us that distinct ID for each one of those merchants, right? And so the difference with row number is it's going to add the row number on all of them. The partition, if I was going to partition by this A, it's going to be 1, 2, 3, 4, 5 up to here. In fact, let's go ahead and do that here as well so that we can also compare. So if we were to do row number over, and then we're going to say partition by merchant, and then order by merchant, and we're going to call this partition ID. So if we were to run this one, it would be as we would think, because technically if we were partitioning by, in this case, this AAA, there's actually 5 of these values, right? If that's what our definition of duplicate was, then yeah, there's 4 extra values here. But if these are different products for different merchants, and we wanted to rank these merchants, each of these merchants with their own ID, then we would use dense rank. For the partition ID, if we wanted to look at the number of those values within their value, then we would use the partition ID. And then if we wanted to look at the row numbers overall, we would of course use row number. So this shows us where we can, an example I should say, of how we can use dense rank. And then we see this example related to some of the other examples we've covered in comparison.